Hello everybody, so we're going to be covering today chemical equations, what they are, where they can be used, and how to write them. It builds on the work that we've been doing recently to do with chemical formula and how to write chemical formula. If you need a little bit of revision on that, best go back and watch those videos again. We're also going to build on the work we did in S1 and S2 to do with word equations. So hopefully some of this will be familiar. And what we're going to do specifically in this lesson is we're going to be able to write chemical formula equations, and then also state the four state symbols and know how to use them. So let's get started. If we take the example here, we have a recipe essentially. We've got some eggs, flour, milk, butter and sugar. And if you mix those together and if you react them, if you cook them together, you'll get a cake. Now that's analogous to a chemical word equation. We've got the reactants, we call them, on the left-hand side, sorry, so that's the eggs and the flour and the milk. That's the things that we're starting off with. We use an arrow in chemistry as opposed to using an equal sign, and the arrow means literally it reacts to form. And then on the right-hand side, we have the thing that we've made. We call that the product. So let's just summarize that. So we have the reactants on the left-hand side, our starting materials. We use an arrow, which means reacts to form. And then we have a product on the left hand, a product on the right hand side, which is the thing that we've made. So we have an example here. We have when methane is burned in oxygen, it produces a gas, carbon dioxide, and water. So in this example here, let's go through it. What are the reactants? What are the products? And what is the word equation? So what are the reactants? What do we start off with here? And what are we producing? So I've color-coded this now. So the reactants are in red. So we start off with methane and oxygen. So when methane is burned in oxygen. So those are our two things that we're starting off with. Our products I've then put in blue. So the things that we're producing, well, it even tells us it produces a gas, which is called carbon dioxide, and it also produces water. So we can put all that together. We want the reactants on the left-hand side, followed by an arrow, and then the products on the right-hand side. And so our word equation would be like so. Methane plus oxygen reacts to form carbon dioxide plus water. And this tells a chemist exactly what's going on in this particular chemical reaction. So I have some examples for you here. I don't want you to do the formulas for these. I just want you to do the word equation. So have a go at these. Pause these and then we can go through the answers. Okay, so the first one, lead nitrate reacts with potassium iodide. Well, those are our reactants, okay? They're reacting together. This produces a yellow solid, which is called lead iodide, and a clear liquid called potassium nitrate. So that gives us this word equation. So just pause and check that you got this one correct, please. Next one, to make sodium chloride, one possible method is to react hydrochloric acid and sodium hydroxide. This reaction also produces water. So there's always a clue, or not always, but there's more often than not a clue where it says this makes or this produces, and that would therefore obviously be our product. And here's our word equation for this one. And last but not least, this one's a little bit difficult because it's all kind of mixed up a little bit. So pause and have a go at this one and then check your answer, please. So here we go. So we have magnesium and oxygen are our reactants. They react to form magnesium oxide. Now the last sentence in this one here, heat energy is needed for this to happen. That's kind of put in there to throw you off the scent a little bit, because we don't put heat energy in our chemical word equation. The reason being is because energy is not a chemical. So some of you may have put that in there, but it shouldn't be there. So there we go. Magnesium plus oxygen goes to reacts to form magnesium oxide. Now this is where we sort of move on to National 4, National 5 work. So we've been learning over the last few weeks how to write the equations of our elements, ionic and covalent chemicals using the various different methods that we've been teaching. What we need to do now is we need to use those methods to work out what's called a chemical formula equation. And the reason why it's called a chemical formula equation, as you can probably guess, is because we use the formulas, and instead of writing a word equation, we would write the equation with chemical formulas. So here's how we do this. With our lead 2 nitrate, we need to use the balancing charges method because it's ionic. We have lead, which is 2+ charge. The nitrate is NO3 negative. Remember, you can just look in the back of your data book to work out what nitrate's formula is. We need 2 of them. Therefore, we need to put that in brackets. So we've now got the formula for lead nitrate. We do this, we basically follow the same method for every single chemical that is within our chemical equation. Potassium iodide, potassium is K+, iodine is I negative. We need one of each, so it's Ki, and then the same, we carry on and on. So what we've got now, we've got all of the formulas of our chemicals. So we can now put them into a chemical formula equation, which looks like this. So it's quite a long process, certainly when you're starting off learning these, because you have to go through the methods for every single one of the chemicals. What I find a lot of people do at this stage is they forget to use all the rules that we've learned. They would see lead nitrate and they would have lead nitrate as just PbNO3, or they would have lead 2 iodide as just PbI. They just take the names and stick the chemicals together without actually working out how many of those chemicals you actually need. So please don't fall into that trap. Let's have a look at some more examples. So we've got 2 more now. Why don't you guys have a go at these? So the top one there, magnesium plus oxygen goes to magnesium oxide. Well, magnesium and oxygen are elements. Hopefully you've remembered that oxygen is a diatomic element, so it has the formula O2. The magnesium oxide is ionic, so we would use the balancing charges, and that gives us the overall formula of MgO. With the next one, here's the answer. So pause and have a check to see if you got this. So the next thing we're going to do is look at something called state symbols. So you may be familiar with these already, but if they're not, or even if you are, let's go through this. So when writing a formula, you can indicate the state of the substance by writing a state symbol. So the state would be whether it's a solid, a liquid, or gas, and we've got one more we're going to look at afterwards. Let's take the example of ice. Well, ice is a solid. The formula is H2O. We use the state symbol S and it has to be in brackets and it goes after the chemical formula. It also goes in subscript, which remember is below the halfway point of that formula. If we take that solid, we can also melt it and we'll turn it into a liquid. The state symbol for a liquid is L, and again, it goes after the formula of the chemical in subscript. And you may be able to predict the next one. It is a gas, and it is G for gas. Okay, so nothing too challenging there, hopefully. There is one final state symbol, and if we take a solid and we dissolve that in water, we would say that that solid is in solution, or we would say that it is aqueous. So an example would be, if I have copper sulfate, well, that's now in the solid form. That's the crystals of copper sulfate there. I can add it to water, and that water will dissolve the copper sulfate. Well, that will now produce a solution. And the state symbol that we use for a solution is AQ for aqueous. What I'd like you to do now is to pause, and I'd like you to write down the formula with the corresponding state symbol for these chemicals, please. So liquid nitrogen, hopefully you guys got that it's N2 because nitrogen is a diatomic element. So when it's on its own, not reacted to anything else, like in NO3, for example, or NH3, if it's on its own, the formula is always N2, and it's L for liquid. And there it is after the formula in subscript. Solid carbon dioxide is CO2 with an S after it. Sodium nitrate solution, NaNO3, the solution part is represented by aqueous, AQ in brackets, hydrogen gas, H2 with a G after it, and then nickel 2 chloride solution, NiCl2, brackets, AQ close brackets. So our final thing is to put all this together. Can we take the formula of a chemical and the state symbols and work out what the formula equation is? So we've got calcium metal plus oxygen gas goes to calcium oxide powder. Sodium chloride solution plus silver nitrate solution goes to silver chloride solid and sodium nitrate solution. So again, pause and then work your way through these, please. So the first one, the calcium metal, well, it's going to be a solid in this case. Oxygen gas is going to be O2 with a G, and then calcium oxide powder, well, the only way it can be a powder form is if it is in a solid state. And our next one, we have two solutions to start with, and then the silver chloride is a solid, and then the sodium nitrate is also a solution, so 3 AQs and 1 S. And that's everything. So if you guys can get the Google form to your teacher as soon as possible, and we'll get our feedback to you. Thank you for watching, and if you have any questions, please get in touch.